Hi, this is Subarna Pokrel and my partner is Mohammad Hamid. We're doing an AI project on tic-tac-toe implementing Minimax algorithm. Firstly, I want to show you the tic-tac-toe we designed. We all know tic-tac-toe works, how it works, and most of us have played throughout our lifetime. So, say the game starts with X. There are three of a kind in a row, in a column or a diagonal, then that symbol wins. Like over here, O wins. The basic code for tic-tac-toe we have implemented is as follows. We initialized variables, player 1 and player 2, and we load the form in the memory. We created flags and we counted the number of hits so we can check. I want to go straight to the check method, which is the main code for verifying if a player wins or not. A player can win either in three of a kind in a row, three of a kind in a diagonal, or three of a kind in a column. So we are just trying to verify if the text on every button, every click, resembles in a diagonal, in a column, or a row, and then the player wins and the win counts. Now let's go to the actual design of the form and see how it works one more time. As we see, the game starts with X, next move is for the O, the turn shows whose turn it is, and as soon as the player wins, the winner recorded. For the Minimax algorithm, however, we use a long process, and then we used different methods. We use is the board winning for X player, is the board winning for O player, and over here we selected X as a computer, as a human player, and O as a human player. So to figure out the heuristics of the instance of any board, we figured out the number of empty cells of that board and collected the indexes where the cell is empty. Now we initialize a variable best move of the index, and then we implemented Minimax. Minimax is a recursive algorithm which determines what will be the next best possible move. If player X is trying to win a game, player O will try to reduce X chances by placing zeros in certain positions. So these are the codes we wrote. We found out the depth of every instance by using getDepth method. We found out the move of what would be the best possible move after implementing Minimax algorithm. We created a button called AI player initialization, where the first move is always made by X, which is an AI player in our case, and then we use a different method to run along with the AI component. Like when there were two players who were playing, we use a different method, and whenever the AI player, when a human player is playing against AI, we use a different method. over here the red squiggly sign comes because there are two different methods with the same name. Let me comment that on top. There we go. Now the code is complete. We were not that much familiar with C# using Visual Studios, so although the algorithm works perfectly, we verify the algorithm by tracing it from top to bottom several times, and it works perfectly. But every time we try to run it, our form doesn't accept the right input, and it's not giving us the right result. Nevertheless, what we are trying to do over here in the Minimax algorithm is we gave 3 arguments. We gave the board, we were going to be the player, and the depth of that board. First, we figured out what are the indices that are empty in that board and stored the indices in an integer array. Now we verified it against if the depth was greater than 0 and less than 9, which is the maximum depth in case of tic-tac-toe. We created an object array called moves, which stores all the possible instances of the button array we have created. And then for every button array at the ith position where the spot is empty, given by empty spots array, we assign the text as a player. In this case, AI player will be X and the human player will be O. And then we created another button array called move and allocated the given array to the button array move. Now, since Minimax evaluates the minimum and maximum value on the basis of the heuristics of the preceding depth, we figured out the move value for each in an integer array called move value integer. We figured out the winnings from the heuristic calculating method over here, and it returns the winning for each value and store it in an integer array. So, and then we initialize this maximum value and the minimum value, and whenever the maximum value is more than the value of the ith item, it records that, and using the for loop we figured out the minimum and maximum value of that instance. Now if the player at that instance is the AI player, the best move index will be the maximum value, because the AI player will always try to maximize wins. Else, it's going to be the human player with the minimum value. So when we call that function recursively at the move method, it will return us the given array's text with either the maximum value or the minimum value, depending upon whoever the player is. In our case, it's going to be an AI player. So this is all about the codes. Whenever we try to run it, and initialize start with an AI player start with X, and then we put our input and the game continues. So that is all from Subarna Pokhrel and Mohammed Hamed. Thank you.